Okay, I'm at the Arduino website. Here's the home page. What I'm going to do here is I'm going to go to Learning, go down to Examples. Today I'm going to be doing the it's under Analog section number 3 right here. It's called Analog In-Out Serial, which is read an analog input pin, map the result, and then use that data to dim or brighten an LED light. Basically what that means is I'm going to use a potentiometer, and depending on the input of the potentiometer, it's going to control the output of an LED. The brightness of the LED will be dependent upon the position of the potentiometer. Hope that makes sense. Anyway, this is the analog in-out serial. We'll click on here, and I'm gonna zoom in a little bit. Okay, just to show you guys. What you need is an Arduino board, a potentiometer, an LED, and this calls for a 220 ohm resistor. Here's the actual circuit. Shows potentiometer. I got basically 5 volts here, ground, and this potentiometer is outputting to the analog 0 pin, and there is an LED that's plugged into ground on the short side, and the long side of the leg of the LED has a 220 ohm resistor going to pin 9. Let me show you the probably make more sense looking at this schematic here. Let me zoom in a little bit. And basically this is the 5, from here is the 5 volts, comes down, goes to the variable potentiometer, which is basically a variable resistor. So the potentiometer gets 5 volts on one side, the other side gets ground, and the wiper, which is the signal wire, sends the input to the A0 pin, and the LED, the short leg of the LED goes to ground, the long leg goes to a 220 ohm resistor, and that gets plugged into pin D9, and this particular pin is a pulse width modulated pin. It's actually the pulse width modulation that controls the brightness of the LED. Basically a pulse width modulation is a square wave pattern that, depending upon how you manipulate the square wave, you can turn something on, and depending on the duty cycle of that pulse width modulation. In other words, if you have the square wave 50% on and 50% off, well, it'll be about a 50% duty cycle, which should send 50% of the available voltage to the light. If you have 10% on and 90% off, well, that's like a 10% duty cycle, and it should send like 1/10 of the voltage to the light, which would make it dim. But basically that's what pulse width modulation is. And of course down here, this is where all the code, the code explanation tells you a little bit about the code for this project. Simple as that. Okay, now I'm going to go to there's my big fat cat Maggie. Anyway, Arduino icon. I'm going to go up here to File, come down here to Examples, look under 3 Analog. I'm going to go to the Analog In-Out serial, and there's all my code and everything. So let me get this ready. I'm going to make this big. You just got to come up here to the top and click on Verify, and it'll compile and check it for you, check the code out. If there's a problem, it'll tell you. And then I'm ready to upload. But before I upload, I'm going to show you the circuit I got here. Okay. And based off that schematic, I mean, here's my potentiometer. I'm using alligator clip jumper leads, and I got red's 5 volts, green is ground, and red is 5 volts, black is my ground wire, and green is my signal wire. And if you follow this back, it's just, I got my alligator clips plugged into these, you know, they're going to these little pins. So as you come on down here to the board, this here, I don't know if we can see this or not, but this is my 5-volt pin. If you go this is 5 volts, this is a ground, the black's ground, and the green is going to A1 analog pin. I'm sorry, A0 analog pin. So I mean, it's just 5 volts ground and signal wire, analog in. And here I have red going to number 9 pin, pulse width modulation, and this is the ground going to ground. So I got ground here and pin 9. Pin 9 comes in, goes through the LED. Short leg goes to the resistor. Resistor comes out this side and goes to the ground. Hope that makes sense. But let me look at it this way. Maybe it'll make better sense. So I'm just using 1, 2, 3, these 3 rows. See, ground goes to this side, and actually I'll just hook it up real quick just to show you guys. As you can see, I got the ground on this pin. This one, there's nothing hooked into the middle one, and so you got pin 9 here, ground here, and 1 in between. See how now the short leg goes right in the middle here, like so, and the long leg goes on the red pin side. So like that. Now connecting these two, I'm going to use my resistor to go that way. So basically, resistor is this one and the middle one, and the LED is the middle one in this one. Hope that makes sense. Anyway, okay. Well, I'm going to plug this board in. And going to upload this code here. Click on upload. It's uploading. It says compiling, uploading. Now it's done uploading. I'm going to I'm turning the analog, the potentiometer, and you can see it's getting dimmer. It's out. Brighter, brighter, brighter. That's all the way bright. Now let me turn it the other way. It should be getting dimmer, which it is. And it's all the way dim. All the way bright. Go a little faster now. Okay. Now I'm going to show you the serial data on this, so you guys get an idea of what's going on here. Okay, looking at the computer. Come up here to Tools, come down here to Serial Monitor. Now this is going to monitor both the sensor and the pulse width modulation of pin 9. It's monitoring both. Alright, let me go where you guys can read this. Okay, now what I'm going to do is I'm going to start turning the potentiometer, and this should monitor. Right now I got it completely turned off. As I turn it up, the sensor value changes and the output value changes. Okay. See how the sensor goes all the way up to 1023, and the digital output goes to 255. You notice when they're related to one another. and it's based on the brightness. Just to show you guys that it's programmed to do that. This tells the sensor, it basically assigns a value for the input of the analog from 0 to 1023, and based upon the position of the sensor, it assigns an output value between 0 and 255. Well, you can see how they're related.